some of you are physicists, chemists, human development, home science, uh, food and nutrition, management. So I understand this group has a variety of background. And my challenge was to select a topic that will at least connect in some point to each one of you. And that is why I have selected a topic that are we alone? Because if I talk about chemistry, rest of you will be offended. If I talk about biology, then most of you might be offended. So I wanted to talk something out of this world, at least out of this earth, so that people will think that, okay, this is somewhere connected to us and all of you would be interested. This question, are we alone, has bothered, I shouldn't say bothered, but has interested mankind for a number of thousands of years. If I want to know the students' population, what are they from? They are science or home science or
Arts and
Arts.
science, third year level, final year.
okay, arts as well as science. Okay, so can somebody tell me how old is a human species? આપણે human is English okay, or you want me to mix the language?
So English is okay.
I'm asking students. Tell me what you will prefer. Okay, good. So, can somebody tell me how old is a human species? Homo sapien, we call it scientifically. When did we develop, and how old we are? અનાદિ કાળથી આપણે અહીંયા છીએ, પણ એ કેટલા વર્ષ? Human species developed about 1 million, that is 10 lakh, about 1 million years back. And at that time we were in Africa. And about 100,000 years, like 1 lakh વર્ષ પહેલા, we started spreading to all the region. Some of us went to Europe, some of us came to India, and some of us went to America, American continent, and likewise. So we are about 1 million year old species, and in that 1 million years, there are two major achievements of mankind. Two major achievements. Can somebody tell me what is our achievement in 1 million years? I'm not talking about last 100 years, computers and iPhone. That's achievement, but that's a different kind of achievement. I'm talking about in 1 million years, what are the two major achievements that we have?
Fire and will.
Fire and will.
Fire and will. Okay, anybody else?
Language.
So civilization and language.
Okay, he is on the track, civilization. One thing we learned is how to stay in a group. Small group, then larger groups, then countries, tribes, and then small countries and larger countries. And now even we live in the community of nations, the United Nations. So our one major achievement was that we learned how to live in a group. And second major achievement was agriculture in a way. We are in directions, but not quite. The second major achievement was our scientific thinking. We used to think even earlier when science was not there. Science is only about 300 years old. The solid science is only about 200, 300, 400 years old, although some rational thinking was part of us even before that. But even when we didn't have the second major achievement is that we think in a way that science teaches us to think, and that is rational, objective observations and analysis. બહુ ફરક છે આ બંનેમાં. પહેલા પણ લોકો વિચારતા અને અત્યારે પણ વિચારે છે, પણ સાયન્સથી વિચારવાનું એક બહુ અલગ વાત છે. અને પહેલાં જે આપણે વિચારતા ત્યારે આપણી પાસે આપણે જે આંખથી જોઈ શકતા અને કાનથી સાંભળી શકતા એ જ આપણું વિશ્વ હતું. વી સો દેટ સૂરજ આમથી ઉગે છે અને આ બાજુ આથમે છે, તો આપણું અન્ડરસ્ટેન્ડિંગ એવું હતું કે ભાઈ સૂરજ આમથી આમ જાય છે. પણ ખરેખર આપણે જે સેન્સરી ઓર્ગન્સ છે એના પ્રમાણે બરાબર છે. પણ જ્યારે સાયન્સ આવ્યું તો આપણે વિચાર્યું કે ના ભાઈ સૂરજ કાંઈ નથી જતો, આપણે એમની આગળ પાછળ ફરીએ છીએ. સો our earlier understanding was limited by our sensory organs, but later on science gave us a lot of instruments so that we started collecting data, objectively observing things, and we developed the whole science. આમાં થયું શું કે આપણું નોલેજનું બહુ એક્સપાન્શન થયું. કેન આઈ હેવ સેકન્ડ સ્લાઇડ? આપણા નોલેજનું બહુ એક્સપાન્શન થયું, પણ સાથે સાથે નોલેજ ફ્રેગમેન્ટ થતું ગયું. Now we say she is from science and she is from arts, somebody is from physics and somebody is from human development, etc. etc. આ જે ફ્રેગમેન્ટેશન જે થયું છે that has handicapped us in a major way. ખરેખર અને એમાં આપણી જે એજ્યુકેશન સિસ્ટમ છે, I am mixing both the language because some things are so that it can be best conveyed in one language, best understood in another language. એ પ્રમાણે હું જાણી જોઈને મિક્સ કરું છું. તો we were curious. Curiosity has helped us to develop knowledge. But earlier we were limited by sensory perceptions. The next slide. But our knowledge should be overall knowledge. Our knowledge is not fragmented. It should not be fragmented. It's an overall knowledge, and that knowledge is about our universe, about ourselves, and about all our activities. So the knowledge domain, what we call human dimension, it includes all of these things: what we are, what our universe is, and what our activities are. Economics is our activity. Agriculture is our activity. And our activities are also a part of the knowledge. But one thing that we should keep in mind, especially students, is that we should break this wall. This compartment wall has hurt us, has limited us. We have to think in a broader perspective and try to see everything in a connections. Now, why I am emphasizing this point is that most of the future problems that your generation will face would not be solved by a physicist or a chemist or a sociologist or a psychologist. Most of the problems will require a combined team approach comprising of people of various disciplines, and then only we will be able to tackle most of the problems of the future. Are you with me?
Yes,
students?
sir.
Huh? I am, even I was vice chancellor, but I take some guilt that we have made our education system so compartment and such a tight compartment that we don't let students understand little bit of economics if he or she is pursuing studies in, let us say, pharmaceuticals. તો આ જાતનું એક cross learning is very important, and in that connection I will give you one example. Next slide. You can see this slide. આ સ્લાઇડમાં જે x axis છે નીચે, that is the pollution indices, particles number, density of particles, અને પહેલામાં છે ઓઝોન લેવલ. અને y axis છે, it is a violent crime, incidences of violent crime in United States. Now tell me, this correlation is, as you can see, the pollution level of particle number increases, there are more incidences of violent crime. And in that one, when the ozone level is increasing, you can see there's a similar increase in crime. Now, this is an example. This is a real study in United States. Now tell me which subject this topic belongs to. Is it environmental science or a sociology of crime or the public governance? Who will help us to understand such phenomena? Not one,
All of the above.
but a interdisciplinary team can help us to understand this kind of phenomena. And likewise, there are n number of examples. So to young people, I want to say that the future challenges will be of this type. And the compartments that we have kind of developed in your mind, that physics is different from chemistry and biology and social sciences, I think you should slowly dismantle those walls and try to think in a very open and a very cohesive way, that everything is a knowledge, everything is a, if it is developed scientifically, everything is a knowledge, and to understand that, rather than doing individually, it would be good to have a collective, multidisciplinary team. Okay? The next one. So our future is where everything is around us, and rather than looking at one at a time, I think we have to teach students to imbibe aspects of many things. My students complain, સર એક વિષય બરાબર સમજાતો નથી અને તમે એમ કહો છો કે બધા વિષયમાં એક્સપર્ટ હોવું જોઈએ. I'm not asking you to be expert in every subject, but overall understanding of every other subjects and depth understanding of your subject will make you a good team player, and that is what young people should learn. So for that, give me this one. So space biology is one such interdisciplinary subject. An aspect of space biology I will talk about in another half an hour or so. Imran bhai, time છે ને એમને?
બિલકુલ સર.
Okay, next. So what is space biology? It has two aspects. One, is there other life elsewhere in the universe? And we will focus on this aspect today. Is there a life elsewhere? And this question is not new. Our ancestors and their ancestors have always been thinking that what is there in those heavenly bodies that we see in the sky, and we relate them to our ancestors, we relate them to our gods, and we have always put them in the imagination of our being. One limitation was that it was all based on our sensory system. But with instruments, we can study them better, we can study them in depth, and what we will try to address today is, do we have our cousins on other planets, and do we have our cousins on other galaxies, and if there are, how do we find them? Is that interesting enough?
Yes, sir.
Huh? Okay. And the other aspect of space biology is that our life has developed on Earth under certain circumstances. Now when we go in outside in the space, now how our physiological well-being is affected, and what આપણું શરીર જ્યારે આપણે અવકાશમાં સ્પેસમાં જઈએ તો શરીરની બાયોલોજી ઉપર એની શું અસર થાય. That topic I am not discussing today, but if you are interested, some other time we can discuss. આજે આપણી ખોજ છે કે આપણા ક્યાંય ભાઈ બહેનો બીજા પ્લાનેટ ઉપર છે કે નહીં, અને છે તો એ આપણા જેવા છે કે આપણાથી વધારે સારા છે, આપણાથી વધારે સમજદાર છે, અને કદાચ આપણા જેટલા ઇવોલ્વ ના થયા હોય તો પ્રિમિટિવ લાઈફ હોય તો એ પણ કેવી છે અને કઈ રીતે એ બની છે. That is our interest for today. The next one. So it addresses three fundamental questions. How does life begin and evolve? first on the earth, if we understand that life began and evolved in a certain way, then we can try to examine whether similar conditions could have been present on other planets, and if there are other similar conditions, planets with other similar conditions, whether there is a life. So we have to understand what is life here, how did it evolve, and then we try to examine similar phenomenon elsewhere. Is there a life beyond Earth, and how can we detect it? And what is the future of life on Earth and in the universe? Now, I'm not a Jyotish, so I will not say what is the future of life on the Earth, but that is left to the generations and next generations. They have to decide what future we want to make of ourselves. But if there is a life, then how do we, what does it progress to? What is the next step in evolution? Are we the end of evolution, or we can evolve in some better or further way? The next. So this question has been there, and it is an interdisciplinary questions, but it has been people have been interested in this from ancient times as well. The next one. Now, one way to study the space is what is known as an International Space Station. I don't know how many of you are familiar with, but a very large space station has been established roughly 400 kilometers away from Earth, and that is a permanent station. And on this permanent station, there are a spacecraft going from Earth. Can you see the aircraft, kind of the spacecraft?
Yes, sir.
This one. So, from Earth, when spacecraft goes to that ISS, we call International Space Station, it can dock on that, and there can be an exchange of astronauts, there can be exchange of materials, and there has also been exchange of many experiments. Some experiments that we cannot do here, we have been doing it on that ISS, and that ISS is a permanent platform. It was developed by 5 different countries, collaboration of 5 different countries, and it is very helpful to understand the space and the space physics, the space chemistry, space biology, and all other. Our understanding about the space has largely developed because of ISS. And ISS started about 20 years back. The next slide. Yes. So the International Space Station is in collaboration with NASA, which is the American Space Agency, Roscosmos, which is a Russian space agency, Japan's space agency, Europe, and Canada. So these 5 countries, actually Europe itself is a club of about 20 plus countries. So these many countries have collaborated and established this permanent station. It orbits about 250 miles, that's about 400 kilometers above the Earth. And you can see that it orbits at a very high speed, about 4.7 miles per second. And its length is about 50 meters, and the width is about 110 meters. So it's just like a huge football ground, permanently spaced, and then we can have a communication, we can have an exchange of astronauts as well as information experiments with the space stations. And that is how most of these things. And its weight is 420,000 kilogram, approximately about 300 plus cars. So it's a huge permanent platform that is used for investigation in the space and the space biology. The next one. Now, brief history of our solar system. That, you know, the Big Bang started about 13.8 billion years ago. Yesterday I talked about a history of about 2000 years. Imran Bhai. And today we are talking about a history of about 13.8 billion years. That is when the Big Bang was the initiation of our universe. And in that, our